airplane on display here at the Museum of Science in Boston, Massachusetts is called Daedalus. It may not look like your average airplane though. That's because instead of getting its power from fuel, this airplane uses human power to fly. Daedalus was designed by engineers from the Massachusetts Institute of Technology. See, engineers are creative people, but they don't just use their imagination in their work. They use what they know about math and science to solve everyday problems, such as making sure we have good, clean drinking water. Engineers also design lots of cool new things, like faster roller coasters or bubblegum that doesn't lose its flavor, or even everyday things like the mouse for your computer or remote control for your TV. Engineers work in all kinds of places. Well, take Malcolm, for example. Malcolm is an industrial engineer at a potato chip factory. Today is Malcolm's day off, so he's decided to spend it hanging out with his little sister Aisha. Let's see what they're up to.
Malcolm, it's the weekend. You said we could do something fun today.
Okay, we'll do something fun, I promise. Why don't we go into Boston today? There's a ton of stuff to do there. Just give me a few minutes to finish up what I'm working on.
Malcolm, I don't get it. What do all these books and drawings and stuff have to do with working at a potato chip factory?
Well, at the factory, I work as an industrial engineer. I work on finding ways to improve the machines and the systems that the factory workers use. This way, jobs are easier and they don't get hurt when they have to lift lots of heavy crates of potatoes.
Oh, I see. I guess.
Watch this. Okay, I want you to pretend that these books are a crate of potatoes that just came off of a truck at the factory. Your job is to push this crate across the table.
Okay. Whoa, that's hard.
I know. The workers at the factory have to lift and push heavy crates of potatoes all day long. And sometimes that can hurt their arms or their backs. That's where I come in. Watch this. All right, now try.
Whoa, that worked. That's much easier now. How'd you do that, Malcolm?
The pencils act like little wheels and the stack of books rolls along it as you push it. Much easier than sliding the heavy books across the table by themselves. At the factory, I try to figure out ways that we can use wheels and other simple machines.
Simple machines. We studied that last year in science class. Things like levers and pulleys and inclined planes, right?
Exactly. You've got a great memory, Aisha.
Thanks. So when are you going to bring me into the factory so I can check out these simple machines for myself, huh, Malcolm?
Are you sure you're not just trying to get some free potato chips?
No.
All right, how about this? I'll take you with me to the factory later this week if you show me that you understand the work I do there.
I don't know, Malcolm. That sounds kind of hard.
You can start today. When we're in Boston, I want you to be on the lookout for simple machines. I bet you'll find them all around. If you show me what you know about simple machines, then I'll show you how I use them to make work easier at the factory. Deal?
Deal. I better go get ready.
All right.
Malcolm and I had a great time in downtown Boston. First, we stopped at Boston Common. While we were walking, I spotted my first simple machine, a wheel and axle on a bicycle. Malcolm was right. There really are simple machines all around us. Then we passed by the Massachusetts State House with its white pillars and huge gold dome. After that, we saw the Afro-American History Museum and Abiel Smith School, the first public school for African Americans in the entire United States. And I saw another simple machine. The American flag on the school had a pulley on it. Finally, Malcolm and I reached our last stop, the Museum of Science, one of my favorite places in Boston. Once we were inside the Museum of Science, we checked out the Rube Goldberg machine, this huge sculpture with tons of complicated little parts, and even some simple machines. I saw a lever, an inclined plane, and some wheels and axles. Can you spot them too? Next, we went to my favorite exhibit in the entire Museum of Science, the huge model of the Tyrannosaurus Rex. Sometimes I wonder what it would be like to see a real live dinosaur. But then again, those teeth look really sharp. After we saw some other really cool exhibits, we went to Malcolm's favorite, Science in the Park. Look! That's a simple machine disguised as a playground toy.
You're absolutely right. Now the question is, what kind of simple machine is it and how does it work?
That's easy. It's a lever. A lever is just a board or a bar, right?
Almost. You're forgetting one more thing.
Oh, right. Wait a second. Doesn't a lever also have a thing in the middle of the board to make it move up and down? What's that called again, Malcolm?
That's called the fulcrum.
Oh, right. Now I remember.
Hey, Aisha,
What?
I bet you can't lift me up on the seesaw.
I bet I can. I'm strong.
All right, let's see what you can do.
Hey, no fair. You're bigger.
Maybe the lever can help you.
Oh, I know. I'll move in towards the fulcrum. Wow, I guess that didn't work.
But there was an important clue in your mistake. Do you have any new ideas?
Oh, Malcolm, you move in towards the fulcrum.
All right, here goes.
Whoa, it worked. Wow, that's awesome.
All right, Aisha,
Oh,
you can let me down now. Come on.
No way.
Well, if you don't let me down, then we can't leave the Museum of Science, and then we won't be able to go to
The
the...
potato chip factory. I was so excited to go with Malcolm to the Cape Cod potato chip factory where he works. I couldn't wait to see how they make all those chips. First, all of the potatoes are unloaded from a huge truck that holds 50,000 pounds of potatoes. After they come off of the truck, the potatoes move into the factory on the dirt eliminator. It has lots of long wheels and axles that bounce the potatoes around so the dirt falls off them. Even the potato chip factory uses simple machines to make work easier. Once the potatoes are inside the factory, they move along conveyor belts into the kitchen, where they are peeled, sliced, and cooked in big kettles until they are perfect tasty chips. After they're done cooking, they move along more conveyor belts until they are cool enough to be packaged. Big machines pour just the right amount of potato chips into bags. Malcolm told me that the Cape Cod potato chip factory makes almost 150,000 bags of potato chips in one day. The factory workers put the bags of chips into boxes to be shipped all over the United States. I wonder where that box is headed. Finally, I got to try some fresh potato chips.
Now you'll get to see what it really tastes like.
They were delicious.
Wow, who would have thought that an industrial engineer would have anything to do with my favorite snack? Actually, I bet industrial engineers are behind a lot of the things that I see and use in my everyday life. I think I'm going to check this out. I'm here at the Cape Cod Potato Chip Factory in Hyannis, Massachusetts with Jeff Mobid. Jeff works as an industrial engineer here at the factory, so he's going to tell us a little bit about what he does in his job.
Good morning, Ellen.
Hi, how are you doing?
Well, we talk about industrial engineering. Primarily, we take a look at equipment. We look to see how fast the equipment can run, how well does it run, what's the quality of the products that are coming out of it. Is it safe to operate? Is it easy to operate for our people? And is it ergonomically safe for our people?
Now, what does ergonomically safe mean?
Well, ergonomics is the study of matching machines to people. So that's really all we try to do is we try to make the machines match the person that's on the line.
So, can you think of a technology that you helped to design that solved problems for workers at the factory?
One example, we had a problem where people would have to pack boxes, and it was very difficult because if they were too tall on it, they had to bend down all day long to grab boxes and it hurt their back. Or if they were too short, they'd have to reach up like this and hurt their shoulders. So we came up with a concept of the adjustable packer stand so that you could raise the stand up or down to place your boxes on them. So when you would pick your bags off the conveyor, you could keep your back straight and keep your arms in close to your body. It made it very, very easy to do this, and it's much, much more comfortable for our people now.
So, what is the most fun part of your job?
Well, the most fun part of my job is problem solving. And all those things you learn in first and second grade, like addition, subtraction, math, little science, things you learn in high school, things you learn in college, you get to use all of it. All that stuff you learned, well, it all matters, and we get to do it here.
That's awesome. And just one more question. Out of all
Yes.
the chips that we see here, what is your favorite?
My personal favorite is beachside barbecue.
Sounds delicious. Well, thank you so much, Jeff, for coming, and I hope you all have a much better understanding of what industrial engineers do. I think I'm gonna try some of that beachside barbecue. Now let's meet some young engineers and their assistants. They're here at the Museum of Science in Boston trying out an engineering design challenge. Their mission? Make a model of a potato chip factory using simple machines to make work easier, just like Malcolm does at his job. Let's check it out.
We're here again at the Museum of Science in Boston, Massachusetts. And today, these teams of engineers behind me are going to improve a potato chip factory, just like Malcolm did. See, the workers at the potato chip factory, they have to lift these really heavy buckets of potatoes over and over again all day long. So, could two of you come on up here and try and lift these buckets of potatoes for me? Heavy, huh? Was that hard? Yeah? So how would you feel if you had to do that over and over again, all day?
I'd go on strike.
You'd go on strike? What your challenge is today is you're going to redesign the potato chip factory to make the work easier for the workers. And you're going to use these simple machines that we have here. So we've got levers, pulleys, wheels and axles, and inclined planes. And you're actually going to be working on the improved step of the engineering design process. So you might want to ask a couple of questions about what the problems are, and then you probably want to imagine some different solutions to the problem. And then you might want to plan and think of what materials you'd want to use and how you'd put them together, and then you can actually create your designs. And then we'll test them and see if they really do make the work easier. What do you think? Are you guys ready? Yeah. All right, let's try it. Still kind of heavy? Yeah. Can you reach?
That's much easier.
You can attach it? Yeah. There you go. Which way should the fulcrum go? That way? I got it right to the middle of the stool. That worked great. So was it easier to lift? Why do you guys think so?
Well, you had to pull it a lot farther with less force.
Exactly. So let's try pulling the cart up the plane. There it goes. So you're gonna use your pulley to move the potatoes through the peeler and the slicer over to the deep fryer? Cool. Great job. So now you're gonna use your lever to move the sliced potatoes through the cooker so they turn into great potato chips. Now that the chips have been cooked and bagged, you're gonna move them up so they can get ready to be loaded onto trucks. Well, you guys made some great designs that definitely made the work easier. But I have a feeling that if you tried, you could improve the factory all over again and make the work even easier for those potato chip factory workers. So what do you think? Should we give it a try? Yeah? All right, let's do it.
Wow, those kids really came up with some great designs for their potato chip factory. Who knows? Maybe one day some of them will become professional engineers, designing a train tunnel underneath the Atlantic Ocean or the new tallest building in the world. And even if they don't become pros, I bet they'll still engineer solutions to all sorts of problems. After all, it only takes some knowledge and a lot of imagination to be an engineer. So, what are you going to engineer today?